In this video, we'll take a very brief high-level view of how the drum is constructed in my model in SOLIDWORKS. So this is not the only way to model this part, and this is not the detailed step-by-step instruction that you'll get in a different video. So please note that this is the high-level view. We're just going to take a look at each feature. So I'm going to come back to my very first step and walk through how I made this part. So this first part is a 2-inch length of 1.5-inch diameter. So this is where we're spooling the wire. Now I want to point out my orientation here. I've got a front view of the square or the rectangular view of the cylinder, and this is my front. And then on the right, I see the circular view of my cylinder. This is going to make laying out your drawing easy. I highly recommend that you orient your own model like this. So that's how I got started. And then I added the end cap. So this cap has a 2-inch diameter and it's an 1/8 inch thick. And I can add the same sketch on the other side to get the same feature. So that's the outer geometry of the drum. This is what you're going to make on the lathe, right? So you'll turn this down and cut to length on the lathe. Now we have a number of holes to make, and this hole is made on the lathe. I think it's this and the shaft hole are the only two. And actually we can make that in one feature in SOLIDWORKS. So if I open this up, this is a counterbore hole, but I chose to use the legacy option here so that I could just set the conditions for the counterbore and the through hole diameter and such. This was just the easiest way for me to set up this hole. So you'll see that there. It's centered on the center of the circle. So this is a pretty simple feature to put in. Beyond that, let me turn the visibility of this plane on. I chose to make a plane that is tangent to the surface and parallel to the top plane. So here it is. So I chose two references. The top plane gives me a direction, and face 1, I can set that up to be tangent. I can flip the offset. If it automatically put this on the bottom of the part, you could choose to put it on the top instead if you wished by checking this box here. So that's the plane. And the reason for that is so that I can put in this hole. This is my, this must be my hole for the set screw. This is not the right size for the set screw, you might notice. This is a number 27. It's simply a number 27 through hole, and the reason for this hole is so that we can get to the material that we want to tap for a number 6 screw. So if we look at the positioning here, it's on the origin, and so that was real easy to put in. What else? If we look at this now in wireframe display style, maybe it will be more clear what purpose that serves. So we have material all the way down here. This is where the shaft will go through. We do not want to have to tap that entire depth to a 632 tap. So we're going to cut a through hole, and then we'll cut the hole for the number 6 tap, and then we'll tap just this bottom length for the set screw. So that's just trying to make manufacturing this a little bit easier. If you've ever tapped, you know that tapping a long distance is not always very simple. So I'm going to keep wireframe on because now we're getting into some interesting holes. So here's my 632 shaft hole. And not a whole lot for settings. I did choose to custom the 632 setting to 0.116. You're going to find that on a drill chart, that's a pretty typical hole for putting in a 632 thread. I choose this option when I'm doing a thread. It removes the thread, which gives me a physical representation of how wide the hole is once the threads are put in. You can choose to specify thread class if you wish. Go back to your notes on threads if you wish to do so, but I did not choose to do so in this hole. And then the position is just at the bottom of that hole. So that's nice and easy. Next step, I put in another plane, and this is to work in a different part of the part. So this plane is going to allow me to put in the hole for the wire. So I'm going to need a through hole for that. And physically, what we're going to have to do to put in this hole is we're going to have to use a flat end mill to make a flat on the part. If you've ever tried to drill on a circular part, it is possible when you're dealing with the very top, but still difficult to do. It's much easier to drill on a flat surface. So we're going to make that with an end mill, and that end mill is going to be 1/8 inch diameter. So that's the diameter of this circular feature, and what we get at the bottom is a flat, and at that flat we can put in our hole for the wire. Oops, I just changed it, so let me come back. This is a number 50. A number 50 has a diameter of 0.07 inches. That custom is fine. And a through hole is also fine. We want the wire to be able to go all the way through this drum. Now we talked about in class how we're going to use hardware to hold the wire in place. So we're going to put in a tapped hole to do that. And I very much want to make sure that the threads of this tapped hole interact with the wire so that it really gets through this and clamps the wire in place. That's going to be one of the tests that determines your grade on this manufactured part. So if I look at these settings, this is a custom hole, again 116 for my diameter, but here's my end conditions for this hole, where the overall hole is 3/4 of an inch and the thread is 0.5. I suppose we could take an extra inch or an extra step and take a little bit of this depth out, but we've decided that 1/2 inch there wasn't too much. Here we took out almost a whole inch, I think, of tapping, whereas in this case we would be taking out maybe 1/4 of an inch. So that's the settings for this number 6 hardware that interacts with the wire. And the very last step is the bolt hole pattern that will allow us to put in the or to attach to the drive gear. So I put 4 holes on this end, and they are 632 hardware. See the custom sizing. End condition here. That's the end condition of the hole itself. The tap only has to be twice the diameter, and that's what it is in this case. My position sketch. Let's come normal too so you can see it. And you know what? Let me turn on wireframe so you can see what's sketch and what's not. So this is a bolt hole circle. It's got 1.25 diameter, and I have 1 hole at the quadrant of at each of the quadrants. So that's it. That is the whole wizard for this last setup. We turn off the visibility on this plane and come back to a wireframe look and an ISO. Hopefully that will get you started. That's an overview, and that's 8 minutes. So clearly if you need some step-by-steps, I'll go through some of these individually in greater detail. So this is just to get you started. That concludes this video for the drum.